In this lesson, we're going to be factoring polynomials by grouping, factoring polynomials completely, and using factoring to solve real-life problems. You have used the distributive property to factor out a greatest common monomial from a polynomial. Sometimes you can factor out a common binomial. You may be able to use the distributive property to factor out polynomials with 4 terms as described below. Factoring by grouping. To factor a polynomial with 4 terms, group the terms into pairs. Factor the GCF out of each pair of terms. Look for and factor out the common binomial factor. This process is called factoring by grouping. So I actually explained how to factor by grouping in my 7.6 video lesson. So if you watched that, you've actually seen grouping before. For example 1, we're going to factor each polynomial by grouping. So for part A, I have x cubed plus 3x squared plus 2x plus 6. So I'm going to rewrite this. And now I'm going to make my groups. Okay, so I'm going to just group off 2 pairs. So this right here, and then this. And then all I'm going to do from these groups is factor out the greatest common factor. Well, here I have an x cubed, and here I have an x squared, so I can factor out an x squared. So I can rewrite this as x squared times, and then just x is left because x squared times x is x cubed, and then just 3 is left going to be here. So plus 3. And then over here I have a 2x and a 6. Well, I can factor out a 2. So this is going to be plus 2 times x plus 3. And once again, I explained exactly why this works more in my 7.6 video. But now I'm just going to rewrite this as x squared plus 2 times x plus 3. And now this is as factored as we're going to get it. Okay, we can't actually break up this x squared plus 2. If this was a difference in squares, then I could, but this is not. So this is all I can do. So now we're done with part A. I'm going to scroll over here for part B. So for part B, I'm going to actually rewrite this in a slightly different order. I'm going to match up terms where I know I can factor something out. So I'm going to rewrite this as x squared plus x, and then plus y plus xy. All right, so over here, I'm going to make my groups. I'm going to put parentheses around these 2 terms and then these 2 terms. So right here, I know I can factor out an x. So it's going to give me x times x plus 1. And then here, I can factor out a y. This is going to give me plus y times parentheses 1 plus x, or I'm just going to write it in the same order as we have in the other one, x plus 1. The order doesn't matter in addition, so I can do that. Anyway, I can use that reverse distributive property to factor out this x plus 1 from both these terms and rewrite this as x plus y, that quantity, times the quantity x plus 1. So now I've completely factored part B, and now we're done. Factoring polynomials completely. You have seen that the polynomial x squared minus 1 can be factored as x plus 1 times the quantity x minus 1. This polynomial is factorable. Notice that the polynomial x squared plus 1 cannot be written as a product of polynomials with integer coefficients. This polynomial is unfactorable, just like the one that we did in the last example. Anyway, a factorable polynomial with integer coefficients is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. So we're going to talk just about some things to check, some guidelines here. So to factor a polynomial completely, you should try each of these steps. Factor out the greatest common monomial factor. So that's either going to be a number or a one-term variable. So here in this example, we could factor out a 3x. So that's what you should try to do first. Then look for a difference of 2 squares or a perfect square trinomial. So in this case, this is a perfect square trinomial. So I can just rewrite this as the quantity x plus 2 all squared. And then for step 3, factor a trinomial of the form ax squared plus bx plus c into a product of binomial factors. So that is what we did in 7.6. So that would be right here. Okay, and then step 4 would be to factor a polynomial with 4 terms by grouping. Now, you could factor this by grouping if you wanted to. There are other ways to factor that as well. But if you have something like this, then you'd have to factor it by grouping. Anyway, these are how you would factor a polynomial completely. For example 2, we're going to factor out these expressions. So in part A, I'm going to factor out 3x cubed plus 6x squared minus 18x. All right, and the first thing I want to do when I'm factoring this is see if I can factor anything out of every single term. Well, I see that 3 goes into all of these coefficients, and I see each term has an x, so I can factor out a 3x. So it's going to be 3x times the quantity x squared plus 2x and then minus 6. All right, so now I want to check to see if I can factor this anymore. So let's see. Well, my b value here equals 2, and my c value here is negative 6. So I want to find two numbers that multiply to negative 6 and then add to positive 2. So they're multiplying to a negative number and adding to a positive number. So I need the signs to be different, and I need my bigger value to be positive. Anyway, let's write out our factor pairs. I have 1 and 6, and then 2 and 3, and that's it. So I need my bigger number to be positive, so I'd have a negative here and a negative here. Well, 6 plus negative 1 is 5. That doesn't work. 3 plus negative 2 is 1, and that doesn't work either. So this is not factorable. So this is all we can do here. So this is in fully factored form. Anyway, we're done with part A now. Now I'm going to go back up to part B. I'm going to rewrite. I'm going to do it over here so I have more space. 7x to the fourth minus 28x squared. Well, the first thing I want to do is factor out anything from both terms that I can. I see I have a 7 and a 28, so I can factor out a 7. And then I have an x to the fourth and an x squared. Well, if I ever have the same variable, that means I can just factor out the lower power of that variable. So I can factor out x squared here. So 7x squared. And then to get from 7x squared to 7x to the fourth, I can just multiply it by x squared. And then minus, well, 7 times 4 is 28. So if I do minus 4 and do 7x squared times negative 4, that'll get me negative 28x squared. So minus 4. But if you notice, x squared and 4 are both perfect squares. So I can rewrite this again using my special products as x plus 2 times x minus 2. All I did is just factor this special case of a polynomial. Okay, so now I'll bring down the 7x squared. And now this is fully factored because I can't factor anything else out of this. So now I'm done with part B. For example 3, we're going to solve 2x cubed plus 8x squared equals 10. All right, so I'm going to rewrite this. (10x) I should say. Anyway, so whenever I'm solving an equation like this, what I want to do is I want to move all of my x terms on the same side and get one side equal to 0 because I'm going to eventually use the zero product property. So I'm going to subtract 10x on both sides. So I get 2x cubed plus 8x squared minus 10x equals 0. I'm going to zoom in here. Anyway, now I want to factor this expression. So first I want to check to see if there's anything I can factor out of each term. Well, each term is even, so I can factor out a 2, and each term has an x in it, so I can factor out an x. So this will become 2x times the quantity x squared plus 4x minus 5. And this is all going to be equal to 0. Anyway, now I want to check to see if I can factor this expression. So I'm going to scroll up. I see that my b value is 4 and my c value is negative 5. So I'm going to write that over here. b equals 4, c equals negative 5. So I need two numbers to multiply to negative 5 and add to 4. Well, you can make a factor list, but I can kind of tell right away that my two values are going to be positive 5 and negative 1 because positive 5 plus negative 1 is positive 4, and then if you multiply those two numbers, you get negative 5. So I can break this up into my two quantities. So x plus 5, and then x minus 1. And I'll bring down the 2x. This will equal 0. Now, when I'm solving an equation like this, just an FYI, this 2 is really not going to matter because what you could do is divide 2 on both sides, and dividing 2 on both sides here, 0 divided by 2 is just going to stay 0. So this 2 is really not going to matter. I know one of my solutions is just going to be x equals 0, but you could write 2x equals 0 if you want. I'm just going to write x equals 0. And then you could rewrite these as well, x plus 5 equals 0, and then x minus 1 equals 0. But for these simple equations, you might just be able to solve them in your head. So I know that negative 5 is going to turn this into 0, and then positive 1 is going to turn this into 0. So x equals 0, x equals negative 5, and I have x equals positive 1. So these are my values that will make this equation true. So anyway, I'm just going to write it in order. So x equals negative 5, comma, 0, comma 1. So anyway, I've solved this equation using factoring and my zero product property, and now we're done with this one. For example 4, a terrarium in the shape of a rectangular prism has a volume of 4,608 cubic inches. Its length is more than 10 inches. The dimensions of the terrarium in terms of its width are shown. Find the length, width, and height of the terrarium. Well, I know the volume of a rectangular prism is just equal to the length times width times height. Well, I'm given all of those. I'm given the length, width, and height in terms of the width, so I can multiply all these out, but I also know that this is 4,608 cubic inches. So I'm going to rewrite this as 4,608 equals my length, which is 36 minus W, times my width, times W plus 4, which is my height. Anyway, what I can do is just multiply these all out and then get this term on the other side. So I have this side equal to 0, and then factor that using the zero product property, getting my values, and then I can find the width. Anyway, let's do that out. So when I have multiple things being multiplied, I can just pick one to do, and then I'll multiply again. So I'm going to do W times W plus 4. So if I distribute that, I'm going to get W squared plus 4W. Let me zoom in here. And then that's still being multiplied by 36 minus W, and that equals 4,608. So now I'm going to FOIL this out. So I'm going to do W squared times 36. So that's 36W squared. And then I'm going to do 36 times 4W, which is going to be 144W. Then I'm going to do negative W times W squared, which is going to be negative W cubed. And then I'm going to do negative W times 4W, which is going to be negative 4W squared. That'll bring down my 4,608. Okay. Now I'm going to simplify this and combine my like terms and write it in standard form. So I'm going to get negative W cubed. And then if I combine these terms right here, I'm going to get plus 32W squared. Then I'll bring down this 144W. And then this is all going to equal 4,608. All right. So now I'm going to move this 4,608 term. I'm going to subtract it on both sides. So I get 0 equals negative W cubed plus 32 I should say, W squared plus 144W minus 4,608. All right. So the only way that we know how to solve an equation like this so far would be to factor this completely. All right, so now I want to make my groups. So I have negative W cubed plus 32W squared, and then 144W minus 4,608. Anyway, what I want to factor out first from this group is actually a negative W squared, because I want to have my first term positive. It doesn't really matter, but over here I see that this first term is positive, and I think that's just going to make my life easier. So if I factor out a negative W squared, I'm going to get negative W squared times positive W, and then this positive term is going to turn negative since I factored out the negative, and then just become minus 32. All right, and then over here, you might not be able to tell, but the only way that this is going to work is if this factor, once I factor out my greatest common factor, this also becomes W minus 32. So I'm going to check to see if 144 times 32 equals 4,608. Okay, so if I do 144 times 32, I get 8, 8, 2. Bring down my 0, I get 12, and then I get 13, and then I get 4, because 3 times 1 plus 1 is 4. If I add these, I get 8, I get a 6, and turns out that we were correct. 144 times 32 does equal 4,608, which means I can factor out a 144 from both of these terms. So I'm going to rewrite this as plus 144, and then times W minus 32. Anyway, set this equal to 0. Now I can rewrite this whole thing as 0 equals, and I could do negative W squared plus 144, and that's what I'll do actually. Negative W squared plus 144 in parentheses, and then times W minus 32. Now what I'm actually going to do is I'm going to factor out a negative from here, okay? And it's not going to matter. But if I have 0 equals negative, if I factor out the negative, I'm just changing the sign in here. So this is going to be W squared and then minus 144. And the reason I'm doing that is because I recognize 144 is a perfect square. All right, so then I'm going to break this up because this is a difference in squares, and I can rewrite this as w plus 12 times w minus 12, and then I have w minus 32 with the negative sign here. Anyway, this all equals 0. So now I can easily tell my w values are going to be negative 12, and then positive 12, and then positive 32. Okay, so these are my possible w values, negative 12, 12, and 32. But it can only be one because you can't have something with the same size that is different widths at the same time. That doesn't make any sense. But if you go back up to the instructions up here, it says its length is more than 10 inches. So 36 minus w is its length, all right? And this has to be more than 10 inches, okay? Well, if the width was 32, then if I go back up here, the length would only be 4 inches, so that's not going to work. And it doesn't make any sense to have a negative width. So my only possible w value is 12. Okay, so if I go back up here, it says we want to find the length, the width, and the height. All right, so here I have 36 minus 12, so that's 24 inches. Okay, so that's one of my dimensions. And then I have 12 inches. That's easy. And I have 12 plus 4, which is 16 inches. So after all that awesome math, I've finally found all my dimensions of this terrarium, and now we're done with this one.